G'day and welcome to the third video on Markov Chains. This continues our discrete random variable series. Now in the first video, or the last video actually, I worked out how to use matrices to find out the number of people moving from one place to another. So, you know, buses and trains and all that sort of stuff. So I'll just quickly go back up to the top of the question again and hopefully we will find it. Okay, so I know that, you know, people change from the bus to the train or the train to the bus each month based on what they did previously, and B was find the number of people using the bus and the train in the long term. Now the reason this is important is because, as we saw in the previous video, the number of people using the bus was increasing, but it was increasing it was actually decreasing the number of that it was increasing, if that makes any sense. It went from 4,800 to 4,920, so it's 120 increase, and then 60 increase, and then 30 increase, and then 15 increase, and then it would be 7.5 increase. Just on that, if it's ever 7.5, you round one of them up and run one of them down. So the top one would be, you know, this one, if that was 5,025.5, you'd make it 5,026, and then therefore you'd make this one 3,374. Okay, so you'd round one up or round one down. Anyway, side point. So it increases, but it's increasing by a decreasing amount. It's actually converging to a particular value. And I guess what I want to find out is what that particular value is in the end. That's the steady state, as we call it. There's a couple of ways of doing this. One, you can do this on the calculator. You can just put in a huge number of changes to see what it would be. So 0.8, you know, the transition matrix, all, you know, imagine I did this 5,000 changes. So after 5,000 months, you know, what the values would be. And if I do that on my calculator, I end up getting 5,040 and 3360. If we have a look at what it was after 4 months, it was 5,025 and 3,375. So it actually hasn't changed that much. It's only gone up 15 since that point. Okay, and n could be any large number. You know, you could try a few others if you wanted to. To be honest, it doesn't really matter what number you use. They actually start to converge quite quickly. So you could even try, for this question here, you could try probably 10 after 10 changes, and it would probably find out these numbers fairly quickly anyway. It does depend on the percentages that are swapping between the two. So that's why I just chose a large number like 5,000, but it doesn't really matter what you choose. Okay, so here's how to do it by hand. We've got the transition matrix here, and I'm going to multiply it by some matrix here, and I'm going to get exactly the same answer. After a while, it doesn't matter how many people are switching from the train to the bus and the bus to the train, because it's like the same number of people who are switching from the train to the bus. Say, let's just say it was, say, 50. The same number of people are switching from the bus to the train. So, you know, if that makes sense, if bus, train, if 50 people are going this way down here, then we know that 50 people are also going this way up here. So eventually we get to the same proportions each time. So when I multiply this transition matrix with a particular number, I'm going to get exactly the same number at the end. You know, this is what we call the, I guess, the steady state matrix. So what I would suspect in this case is that I'm going to, you know, end up with, you know, 5040 over here and 3360 over here, and I want to know what percentage I need to multiply it with over here. I hope this is making sense. So if I multiply this matrix out with this, I'm going to get this value x here, and so I'm going to do that. I'm going to get 0.8 times x plus 0.3 times 1 minus x equals x. You can do it on the other one if you want to as well, so 0.2 times x plus 0.7 times that, but we actually only have one variable, x, and so I'm not going to bother. I'm just going to do it with one. I end up getting x equals 3 out of 5, or 60%. Therefore, the probability of catching the bus is 60% in the long run. And I guess I can multiply that by the total number of people to see how many people I would need to get to the steady state matrix. 60% of the total number of people, 8,400, is 5,040 people who catch the bus, which is the same answer that I got up the top just here. Okay, so when Sorry, there we go. It's the same answer as this one up here, 5,040 people. Okay, so this steady state matrix helps us to understand what proportion of people are changing after a while to make it steady. Hopefully that has helped. And then I can also do, you know, the number of people catching the train as well. Okay, I might do one more video of using the steady state matrix just so that we can understand that in a different context. So thanks for watching.